What lies beneath the surface of a planet that is more water than land? The ocean, covering roughly 70.8% of Earth, hides mysteries that humanity has barely begun to explore, holding the majority of the planet's water and life. This vast blue expanse is not just a backdrop, it is the primary component of Earth's hygrosphere, shaping climate and sustaining ecosystems. As we dive deeper, the question remains, how much of this hidden world have we truly seen? Beyond its sheer size, the ocean acts as a colossal heat reservoir, regulating Earth's energy budget and influencing weather patterns worldwide. This thermal capacity makes the seas essential for climate stability, while also supplying half of the atmospheric oxygen we breathe. Such dual roles underscore the ocean's indispensable contribution to life on our planet, prompting us to ask how these functions intertwine with the biosphere's health. Life itself thrives within these waters. The ocean harbors most of Earth's animals and protist life, and it was the cradle of photosynthesis that transformed the planet's atmosphere. With over 230,000 known species, marine ecosystems provide the foundation for global biodiversity, raising the question of how these intricate networks sustain the planet's food supply and ecological balance. Human societies reap countless benefits from the sea, from ecosystem services and abundant seafood to vital transport routes that connect continents. These resources have shaped economies and cultures for millennia, yet they also expose the ocean to unprecedented pressures. How do our dependencies influence the health of this critical resource? Despite its bounty, the ocean faces mounting threats. Marine pollution, overfishing, and the accelerating impacts of climate change strain its resilience. The continental shelf and coastal waters bear the brunt of human activity, prompting urgent calls for protection. What consequences might arise if these pressures continue unchecked? Sunlight penetrates only the uppermost layer of the sea, defining the photic zone where light drops to just 1% of surface intensity, about 200 meters in open water. This illuminated realm fuels photosynthesis, making it the most biodiverse region and the primary source of the ocean's food supply. How does this thin slice of light sustain such a vast ecosystem? Beyond the photic zone, light dwindles to a few hundred meters before vanishing entirely, giving rise to the cold, dark mesopelagic and aphotic zones. These deeper layers host unique life forms adapted to perpetual darkness, yet they receive little attention compared to their sunlit counterpart. What mysteries linger in these shadowed depths? Temperature across the ocean varies dramatically. Tropical surfaces can exceed 30 degrees Celsius, while polar regions hover near -2 degrees Celsius, and the deep ocean remains between -2 degrees Celsius and 5 degrees Celsius everywhere. These gradients drive circulation, shaping currents that redistribute heat worldwide. How do these temperature differences power the planet's massive water highways? Constant water movement creates a network of ocean currents, propelled by temperature and salinity differences, wind, and the Coriolis effect. Major streams such as the Gulf Stream, Kuroshio, Agulhas, and Antarctic circumpolar current link distant regions, influencing climate and marine life. What role do these currents play in the planet's climate engine? The ocean also acts as a giant gas exchange platform, where dissolved oxygen, carbon dioxide, and nitrogen continuously swap with the atmosphere. Solubility of these gases hinges on temperature and salinity, meaning that warming waters can trap more CO₂, accelerating acidification. How does this delicate balance affect marine chemistry and life? Human-induced CO₂ emissions raise atmospheric concentrations, and the oceans absorb a significant share, leading to a drop in seawater pH, a process known as ocean acidification. This chemical shift threatens coral reefs, shell-forming organisms, and the broader food web. Could the very buffer that sustains life become its undoing? Finally, the ocean's shape is a sprawling, irregular mantle covering about 361 million square kilometers, with remote points like Point Nemo, the farthest pole of inaccessibility, lying 2,688 kilometers from any land. This vast emptiness underscores how much of Earth remains untouched by human hands, prompting us to wonder, what secrets still lie in the planet's most isolated waters?